All right, this is where we're headed. Intro, background, me, FIPS, talk about what FIPS 142 is, what it isn't, right? Why you might be interested in it, and then we'll look at pitfalls in terms of implementation, how to integrate it to a continuous integration or continuous deployment environment, and then finally we'll wrap up with some secure coding gotchas around Beam languages. First, ground rules, right? I am not saying that you need FIPS 140-2 in your life, right? I'm not saying that FIPS 140-2 cryptography is more secure than the alternatives, right? What I am saying is it is what it is, right? If you have to have it, right, in terms of your customers, if it's a requirement, then you need to do it right, right? The other thing is I'm not a lawyer, right? So this is great recommendation, advice. Don't come back and say, oh, you ruined my life. You know, we followed all the instructions in your slides. We took this product to market in the federal space, right? In the end, when it comes to compliance, right, the things that matter is the opinion of your evaluators, your auditors, the information assurance security personnel, and also people evaluating you, for example, in maybe a risk management framework area. So keep that in mind. My background, I've worked in Erlang for the last 5 years as an engineer. Before that, I worked primarily in the federal space, right, either in Oracle's National Security Group, working consulting primarily with defense customers. And so, however, I found a book about Erlang written by Joe Armstrong, and I said, hey, this is a good idea. So for the last 5 years, I've worked in the Internet of Things space with Erlang companies in the commercial area, and that's sort of how we got here. For the last year, I've been writing code as well in Elixir, so I've got a little bit of background on either side of the beam for either of these languages. The company, non-FIPS, we work in the federal space, right? So technically we have commercial clients, we have government clients, but in the end, I have one customer, and it's the U.S. federal government, and so that's who we end up working with. FIPS 140-2 for us means two things. First of all, it means we're supporting government customers in Beam languages now, right? So it's obvious why this matters to us for the current customer group. Additionally, we have a product, right, in development, right, it's going through the cycles that we want to be able to sell in that space, right, in the federal space. So we have an interest in making sure that we have a piece of software that we can sell both to the federal government and to commercial customers, right? And understanding the requirement to use FIPS 140-2 cryptography is going to make it important that we know how to use the crypto properly in the applications, and that's where this comes from. So, so that means who are you, right? So I assume that if somebody's in this audience, either one, they're in the wrong place, right? Or two, you're supporting some sort of Beam language application in the federal space. You have a Beam, some sort of Beam application that you want the federal government to be able to participate with, to be able to use, or that you're considering what if, right? So what if I have this customer and somebody says, hey, I'm a member of the US or Canadian government, we'd like to use your software, but it must meet these requirements. So as I mentioned earlier, I fall into the first two categories. The other thing to remember is that the federal space is what it really means is, typically U.S. or Canadian government customers, and there's the government itself, there's this sort of orbit of contractors who fall around the government, and then some of the information systems, right, that I may need to reach out to or connect to that have these requirements. So what is FIPS 140-2? Basically, it's federal guidance for cryptographic modules, but within the federal acquisition system, it is essentially a mandate, right? It's a bureaucratic process. Certification can take a long time. I feel like the standard's actually really designed first for hardware, and it's kind of been retroactively applied to software, but it is what it is.
Can you give a two-sentence description of what is cryptographic module?
A cryptographic module is, so in this case, yes. So a cryptographic module implements either approved security functions, right, or deterministic random number generation. So this is a module where things occur like, obviously, pseudo-random number generation, hashing, where your hashing algorithms occur, encryption, decryption, right? So that is what we call the cryptographic boundary, right, which occurs in there. So in this case, a FIPS-certified example of a FIPS-certified 140-2 module would be OpenSSL's cryptographic module, or their FIPS module.
So it could be a piece of hardware with a physical boundary, and
yes.
A piece of software with basically no boundary at all.
Correct. Well, the boundary on the software is where you call in the APIs to call into that module to execute those security functions. Right? Yes, absolutely. And so what we end up with is, after going through this bureaucratic process, a certificate is issued, right? And it says this piece of software or this crypto module has been validated by the laboratories and is FIPS 140-2 certified, right? Assuming that, and then the process has to begin again if changes occur. So in the end, if you have FIPS software, really there are two different types, right? You have one which is FIPS validated. My software went to the lab, I paid the money, we spent the time, and we have a certification number, certificate, we can say, hey, we're FIPS certified. On the other hand, we have what's called FIPS Inside. It says, hey, my software, which may be a word processor, for example, isn't a cryptographic application. However, when we do use crypto, we use this module that is certified, and we use it correctly. That is, most of our stuff occurs outside the cryptographic boundary, but when we use crypto, we use 140-2 crypto, and we use it correctly. From a pragmatic point of view, right, from a company in the software business, I also view FIPS 140-2 as sort of a bright line requirement, right? Things you have to get into the federal space with your software. That's what it is from a pragmatic point of view.
Excuse me to interrupt.
Yes.
Can you give a range of costs, how much it costs per 1,000 lines of code to do this?
I can't, because some of it's, I mean, so there's open source options out there, right? I mean, so it's, and we'll talk about the open source options, but I don't know what the costs are to go through and implement it yourself, certainly. So what FIPS 140-2 is, what it isn't, right? I mean, so one of the things we think about in terms of security functions might be hashing, right? You know, I want to take a hash of something, right? And so one thing everybody sort of knows in the FIPS 140-2 world is that MD5 hashing is a no-go, right? It is not considered, because of collisions, because of issues with the algorithm, that it's not a approved algorithm within the 140-2 certification deal. However, remember, Erlang uses MD5 hashing all over the place, right? It's used in terms of Erlang term storage. It's used in terms of disk Erlang term storage, right? It's used inside dialyzer calls, right? However, what's important there is those are non-cryptographic hashing algorithms. That is, they're being used outside of a cryptographic context, right? I'm not here using that to verify the integrity of a message in the exchange necessarily, right? This is just saying, this is the fingerprint of that module. It's not occurring within a cryptographic context. So that's why there's two ways, for example, in the Erlang world to call an MD5 algorithm. We can call it through crypto, right? Or we can call it through the built-in function diff in the Erlang module, MD5. Similarly, we have two explicitly non-cryptographic hashes in the Erlang world, and those are phash and phash2. These portable hashing algorithms are fine, right? Because as long as you're not using them as part of the cryptographic context, right? You can't use them for key negotiation or what have you. So that's part of what FIPS is not. It doesn't affect non-cryptographic uses of hashing algorithms. Beyond that, in this discussion, I will talk as if crypto module in Erlang, and therefore Elixir as well, is the end-all be-all of FIPS 140-2. It's really not. There are a ton of FIPS 140-2 hardware and software modules in the world. If you link to them correctly and use them correctly and respect the cryptographic boundary, you could use those just as well. However, using FIPS 140-2 support built into Erlang is sort of easy mode, right? And that's why we talk about it here as if it is. But understand that there's alternatives out there. Finally, what FIPS isn't is forgiving, right? There's a lot of ways to get it wrong. For example, if we turn off FIPS mode inside the beam, right? What do we get? All of a sudden, the only type of encrypted connection we can use is TLS v 1.2, right? 1.0 and 1.0 are out the window. Forget SSL v3, right? So it limits your options, right? Things that may have started working in the past, if you haven't planned for it, will fail, right? If somebody's calling crypto MD5, for example, for hashing, it just returns unsupported. So there's other implementations out there that ship non-FIPS compliant algorithms with the module and just say, use at your own risk, understand these can't be used in the cryptographic context. But in this case, the OpenSSL implementation it returns unsupported. And that's how it works in the Erlang world as well. Should I enable FIPS mode? If you have to ask this question, the answer is absolutely not, right? Right. If you have to say, I don't know, don't, right? I mean, the answer is no unless you have to, or maybe I want to enable it because at some point in the future, I think I'll need to, right? But it can be painful. Microsoft Windows, for example, ships with a FIPS mode you can turn on, right? They'll have a whole blog article, but don't do it, right? If you have to, you'll know it. And so that's one thing to keep in mind. To get it right requires a lot of pain, right? First of all, you have to go through all the instructions in OpenSSL's FIPS 140-2 security policy. You vary from those instructions, including the command line build for it, by a single instruction, and your installation is invalid anymore, right? Okay, no big deal. Well, then you have to think, well, what am I running in? So I'm running in my Linux environment. Okay, is all of your user space crypto also FIPS 40-2 compliant? Nope. Okay, then you have problems. Well, what about your kernel crypto API? That has to be certified as well. So there's a lot of pain that comes along with it. So you'll know if you have to have it, and in that case, you'll understand the cost. Right? Why does it matter? Right? Why are we interested in this? Right? I mean, the federal government, for example, the U.S. federal government last year spent roughly $90 billion in IT. Right? They're a large customer in this space. Everybody else does it as well, right? For most languages you can think of, there are FIPS implementations, right? Whether it be C or C++. Java has open source implementations, either Bouncy Castle or NSS. Even Golang, right? If you go look in the Golang repositories, you'll find a branch where they're actually using Boring Crypto under the covers, right? And Boring Crypto includes a FIPS certificate on the Google side for encryption. Additionally, there's a lot of interesting problems to solve in the federal space, right? We indirectly support National Institutes of Health in their scientific research and portfolio analysis project, right? So there's a lot of cool stuff to do there. We recently saw a proposal came out, or a request for information said, hey, Center for Medicaid and Medicare Services needs to process $4 billion distinct EDI requests per year, right? So we're talking about text processing, we're talking about high concurrency, high reliability, right? To make sure that electronic data interchanges to provide medical care are successful, right? That's an interesting problem, right? What makes it uninteresting is at the bottom of the solicitation they say, and you really need to be using CICS or COBOL or some message queue from enterprise vendor X, right? And so there's a lot of interesting stuff out there in this area to get towards, right? Another reason it matters is because having OpenSSL FIPS 140-2 mode available to us in the Erlang ecosystem, right? It's kind of like building on the shoulders of giants, right? Instead of having to have some sort of custom software stack to support these requirements, these regulatory requirements within the federal space, we can now use some of the libraries that we're familiar with. And I'm not suggesting, for example, that you should use HTTPD versus Cowboy or Phoenix or Rax or what have you. But what I am saying is that for most of these libraries, they use crypto under the cover, which means that for very little cost, right, and very little re-architecting or engineering, all of a sudden you have an application which can do great things and do it in a compliant manner in the federal space. And based on the conference, I assume I don't have to tell you why you'd want to use the beam to solve problems. But there's lots of ways for these things to go wrong, right? It is everything you would expect from a bureaucratic process, right? And there's lots of ways to go sort of sideways in making sure you've got FIPS 140-2 compliance in your product. The cryptographic boundary, which we referenced, which I talked about earlier, right? This is essentially everything inside the cryptographic boundary is what is certified, right? This is what is validated by the labs during this process through the cryptographic module validation program, right? So this is everything that's certified, right? Great. What's important is that, you know, any cryptographic computations that take place outside of that boundary are not. So from a practical point of view, right? So we're talking if we're only using crypto, the crypto module in this case is our cryptographic boundary. This means that can be the only cryptography that your application is using underneath the covers, and that matters, right? So what it means essentially is that all your computations are occurring in the FIPS 140-2 module of OpenSSL, and you're calling them through crypto. What the mistake that often comes about is that we accidentally extend our cryptographic boundary. So in this case, take a trivial compliant application, right? I set up either mix, rebar 3, pull my repositories. Sure. So under the covers, you know, we're going to use TLS 1.2. Maybe we're using some sort of socket pooling or HTTP daemon of some sort. For password hashing, we can use PBKDF2. Under the covers, it uses crypto, right? So we're safe. The cryptographic hashing algorithms that will be called in PBKDF2 are guaranteed to be safe if we properly put the crypto module in FIPS mode. Sure, great. And this assumes, of course, that that we compliantly installed the OpenSSL FIPS module as well. But things can go wrong depending on your dependencies under the covers or what they pull, right? You've got bcrypt in there, uses blowfish under the covers, the hashing algorithm. Not an approved method. You use Java Web, JSON Web Tokens, right? Under the covers, it uses Java Object Sign Encryption, right? Inside that library, it uses crypto. sometimes, right? But for things, if I'm using Cha-Cha or Salsa, it might use libsodium as its implementation. It also even has the capability to fall back to some of its own implementations, right? Additionally, NIFs and ports, I'm not saying they're always bad, right? But what can happen under the covers is your NIFs or ports can make calls, unbeknownst to you, right? You have to kind of follow this, is to make sure that under the covers, these calls are not making calls out to cryptographic algorithms that haven't been certified, right? OpenSSL, FIPS 1.4-2, or another one, right? It's okay if you do it to reach out to Boring Crypto, for example, and Boring Crypto's in FIPS mode. But there's ways for this to go wrong. Not exactly FIPS mode, but I like to throw this in anyway. Here's what applications typically look like in my environment. HTTPS for us almost always involves client certificate authentication. In my space, in the federal space, it's required to have online certificate status protocol to check for revocation. Erlang supports CRILs, right, certificate revocation lists, but not OCSP. So it's important to know that you're going to typically have to offload that requirement to the front end. So we're going to end up terminating an HTTPS connection. What we'll typically do is we'll take the certificates out of the request, throw them up into a header, right? Either we'll take the whole certificate, base64 encode it like PIM encoding into an HTTP header, or at least pull out something like the common name and start processing it on the back end. The other thing you have to be aware of is distRL. It's not the only deal in town, but it uses MD5 in the handshake going across. However, fortunately, you have the capability to put it in TLS mode and use mutual client certificate authentication. So you can essentially tunnel that MD5 handshake through TLS and protect it with certificate authentication. Walk in the lobby, you'll see people are already interested in this. Our friends at ESL, FIPS 1.4-2 mode in Mongoose IM, supporting public key infrastructure for authentication. So there's already moves in this direction. Now I'll talk about CI/CD, and this is part of, this is how this came about actually, is Francisco happened to see a blog post we had out on the Circle CI website about concurrently running FIPS 1.4-2 mode, just to make sure that, hey, I've got software, and I don't know, maybe someday I want to sell it to the federal government, or I know it's going to be I'm going to have two types of customers, commercial and, let's say, federal. What I do is I use a Docker container out there that's got, Erlang, FIPS mode, OpenSSL, Elixir, and that's what we did with our Elixir app. Don't have to go into too much detail. At the end, I'll have a link that'll actually have the Docker container so you can see how we did it. It'll have a link to the blog article on Circle CI. But it's a nice way to be able to test as you go to figure out. It reminds me of Dialyzer, right? Adding Dialyzer 1 year in is no fun, right? But doing it from the beginning will make your life easier. We got two of those, huh? Cool. Now I'm going to wrap up the discussion with just a little bit of talk about secure coding. Obviously, this is not an exhaustive list, but this is just kind of like some of the areas I've seen pain points for secure coding in Beam languages. Let's go ahead and start. And this is kind of how I categorize them. Obviously, not exhaustive. NIFs, right? Bleeding edge performance. Do you know what the problem is with the bleeding edge? The blood, right? It's great. If you want to get in a Formula One car, do it. Make sure you wear a helmet and a seatbelt. So they'll warn you in the documentation that a crash in a NIF takes an emulator down. I think you're lucky if that happens, right? What you're unlucky is if somebody manages to use it based on memory manipulations or gets access to your stack, for example, and drops a remote access tool. You can imagine how hard it would be if you have a sophisticated adversary, because I don't think a lot of people have the right tools to find malicious code inside, for example, a running Beam VM. Resource exhaustion. Atom exhaustion is kind of unique to Erlang, right? And to Elixir as well. So there's a lot of them we know. We know what the risk is for list to Atom. You may not know that calling HTTP URI parse can be dangerous, right? That in the end it's going to return the scheme of your URLs in Atom, right? So there's a safe way to do it here is to use a validation function to make sure that these schemes, they are safe. It's a good way not to get overflowed. I don't have an answer for XML except for use something else, or you're using trusted XML there, right? But in the end, someone may manipulate your Atom pool. Timing attacks, they're kind of malicious. I find timing attacks malicious in Erlang because pattern matching for us is so kind of idiomatic for the language, right? And so you understand that when you're pattern matching, you're using inequality tests. That's not constant time equality. So in this case, what could happen is where I'm comparing my username to an expected value. An attacker can use sort of a statistical measurement to say, okay, I'm using less instructions, iterate through it, and leak your username. This type of thing happened to OpenSSH daemon, I don't know, maybe a few years back. You don't want to do that, particularly with usernames and passwords. There are alternatives out there. In this case, we use a secure compare implementation, right, which is going to use constant time equality across the board and not leak it. Looks a little awkward. That's it. Bobby drop tables. It's an old classic. SQL injection occurs other places than PHP, trust me. I still see it all the time in the wild. We use shell code a lot. Not shell code, I'm sorry. We use typically binaries located on our file system, right, to do stuff we won't do in Erlang. So that's another place where you can find an injection vulnerability, often calling out via ports. And then finally, property-based testing, right? I mean, everywhere I've worked, and I'm wrapping this up, but everywhere I've worked, people end up doing releases, gets thrown over the wall to the security professionals, and they fuzz it. Why wouldn't you fuzz it in your CI/CD, right? I love this quote from Linus. If you read his email on the kernel list about this, it's a hoot, right? But that's it. We've got great fuzzing tools built into our sort of testing ecosystem, and there's no reason not to use them. I have some references up on the slide, everything from how we do FIPS 40-2 and CI/CD, the documentation for OpenSSL, our containers, which show you how to build everything in FIPS mode, including Elixir containers as well. And thank you. Sure, please.
Yeah, I understand you talk about OpenSSL, but I have a question. Do you have any idea what would be involved in certifying custom crypto NIPs? Because we essentially wrote our own crypto. Sure. It's very lean, does what we need. So what would be involved in certifying the NIPs which are not OpenSSL?
So the question, just to repeat it, is that if you have developed your own cryptographic algorithms, what's involved in going through that process, right? And so I haven't gone through that, but I can tell you there's a number of consultants and people who are in this business to help you get through that. And then the other alternative, of course, is that it depends on how you wire it in. For example, I don't know, are you, for example, using you wrote everything in Scratch from C already to do all your own crypto?
We use the standard functions that we wrote ourselves, and it's very, just between the need. OpenSSL is huge, and obviously OpenSSL is the bread and butter of companies selling 0 days.
Sure, yeah.
With another sale of 0 days waiting to be solved. So
sure.
If you want real security, you cannot really use OpenSSL.
Sure. I can't tell you that, but I can tell you there are a lot of people who can. There are a lot of people who are in the business of helping people go through the process, through the validation labs to get that certificate. And so,
and another related question.
Yes.
When you say that this is certified in Erlang, how do you prove that what you have is actually what has been certified?
So if you go through the security policy for the FIPS 40-2 cryptographic module, that the security policy, that it's actually published on the NIST website as well, and you can download it from the OpenSSL site. And if I've also got a link to it as the first link here. It'll be one of the policies there. It goes through everything you need to do to verify it, from taking a hash with it. It's a chicken and egg problem. For me to tell you that the source code I have for OpenSSL is valid, I have to validate it via hash, but I have to validate it with a FIPS 40-2 certified hashing algorithm, so I have to go get one from somewhere else, right, and go verify that one. A little bit of a chicken and egg problem, but there are instructions, and so it's going to vary per open source distribution, but in this case, OpenSSL has that process. And they've also got best practices around PGP keys as well, that's how you know you've got the source that you wanted or desired.
So if you're selling Erlang appliance, right,
Mm-hmm.
so there's the machine, you box,
Yep.
the whole box. How long is the process to actually certify? And how, when you put a sticker on a box, right, how the owner of the box knows it's really certified?
So it depends whether or not you're doing, so remember there's two different forms of certification, right, or two different forms of compliance. One is validated, right, where I'm submitting here's the whole box. I hand them the pizza box and they say, boom, you're good to go after lab testing, or where it's FIPS inside, where I say, hey, I'm using a cryptographic module that's been validated, and I assert, right, that we've been using it correctly and we've been respecting the cryptographic boundary. So it depends on both of those, right, because you don't have to go through the lab process on that one if you don't own the cryptographic module yourself. How does someone know? There's actually a certificates, published up on the website that says, here's a certificate number, here's the URL to go look at our validation on the NIST website.
So are these signatures based on the source code or on binary?
Sorry, the certificates numbers are just 1,000, or what have you, right? And so they reference the product, right, and the description there. So for example, you would find a certificate for OpenSSL FIPS, whichever version, and the link to the security policy for it. Same thing for BourneSSL. Same thing for maybe a network switch from a vendor like Cisco or Palo Alto.
So it's a business certificate. It's based on trust on people involved. It's not cryptographic certificate.
Correct, correct. So that certificate, sorry, yes, it's an overridden term there, and I apologize. In that case, we're talking about certificate. We're talking about like a participation certificate, right? Well, but, you know, it's like a piece of paper. It says, yeah, you did it, and then it's published on the NIST website. Yeah, woohoo, blockchain. Super. Any other questions?
Yeah. More questions?
Cool.
Okay.
Well, thank you.
Well, thank you.